Welcome to a voyage through time that unveils the extraordinary evolution of our understanding of the universe. Like a symphony echoing through the ages, visionary minds dared to challenge the boundaries of human thought, reshaping our perception of the cosmos. In this captivating exploration, we'll delve into history's depths, where luminaries such as Copernicus, Bruno, Galileo, and Kepler illuminated the path towards scientific modernity. Join us for a riveting journey that traverses stars and ideas, each discovery a stepping stone towards a profound comprehension of the universe that envelopes us. As we embark on this exhilarating adventure, we'll unveil the remarkable story of how cosmological thought has evolved over centuries. The evolution of cosmological thought, astronomical renaissance, and the foundations of modernity. In the dawn of a new era, a daring spirit emerged from the mists of the Middle Ages to reshape celestial orbits. Nicholas Copernicus, a Polish astronomer, embarked on a solitary and persistent quest, forging the heliocentric model that displaced Earth from its cosmic pedestal. His bold vision placed the Sun at the center of the solar system, revolutionizing the conception of the universe. Decades of silent labor culminated in his magnum opus, De Revolutionibus Orbium Coelestium, which sowed the seeds of the impending scientific revolution. Copernicus' work was so radical that he feared negative reactions from the church and authorities. He delayed the publication of his major work for years, finally releasing it shortly before his death. Like a spark in the darkness, Copernicus' writings were caught by curious minds and free thinkers. The heliocentric model took root, spreading across Europe and ushering in a new vision of the universe. Copernicus' revolutionary ideas were meticulously propagated by passionate disciples, contributing to the emergence of modern scientific thought. His iconoclastic model laid the groundwork for the astronomical renaissance and inspired generations of celestial explorers. The German astronomer Johannes Kepler, influenced by Copernicus' ideas, initially attempted to reconcile the heliocentric model with Tycho Brahe's precise astronomical observations. In the labyrinth of cosmological thought, a visionary spirit arose, carrying the torch of the infinite. Giordano Bruno, an Italian philosopher and heretical monk, dared to imagine a universe without bounds, populated by countless worlds akin to Earth. His bold convictions led him to the stake, as his ideas challenged the dogmas of the time. For Bruno, stars were suns, each accompanied by its own planets and inhabitants, evoking a constantly expanding galaxy. Giordano Bruno was persecuted for his heretical ideas and cosmological vision. Condemned by the Inquisition, he was burned at the stake in Rome in 1600. Although his fate was tragic, Giordano Bruno's legacy blossomed like an interstellar garden. His ideas about infinity and the plurality of worlds served as a catalyst for future reflection, inspiring generations of thinkers to explore the farthest reaches of the cosmos. Bruno's spirit embodies the courage to question established norms and imagine distant horizons, creating a lasting legacy in the history of cosmological thought. Before his death, Bruno reportedly stated, "Perhaps you who pronounce my sentence are in greater fear than I who receive it." In the Italian night skies, Galileo Galilei wielded a rudimentary telescope, transforming star observation into a symphony of revelations. Lunar mountains, Jupiter's orbiting moons, and Venus' changing phases refuted ancient conceptions and cemented heliocentrism. The era of celestial discoveries was born, fortifying the struggle for a more accurate cosmic vision. The observation of Jupiter's Galilean moons not only supported the heliocentric model but also raised questions about the nature of celestial objects and stimulated scientific debate. Galileo's bold observations did not come without consequences. The heart of the challenge ignited when Galileo's observations were deemed heretical by the Church. The clash between science and faith left an indelible mark on history, illustrating the turmoil between the pursuit of truth and established beliefs. While Galileo was condemned, his revolutionary discoveries sowed the seeds of a new era in scientific thought. Despite being placed under house arrest later in life, Galileo continued his research and wrote one of his major works, Dialogues, concerning the two chief world systems, a subtle plea for the heliocentric model. Beyond telescope lenses, Johannes Kepler, a meticulous mind, unveiled the secrets of celestial motion in a dance of elegant mathematical laws. His three orbital laws revolutionized how we perceive planetary movements. The first law, elliptical orbits, dispelled the dogma of perfect circles. The second, the law of areas, described planets' varying speeds according to their orbital positions. The third, the harmonic law, linked planets' orbital periods to their distances from the Sun. Kepler dedicated his life to seeking harmony in the universe. He was the first to demonstrate that mathematical laws could describe celestial bodies' motions. Kepler's laws were precious keys to unlock the universe's mysteries. These laws perfectly aligned with Tycho Brahe's observations and provided a solid foundation for Isaac Newton's future theory of gravity. Kepler's legacy transcends purely astronomical discoveries, influencing the development of physics and laying the groundwork for an upcoming scientific revolution. Kepler believed there was a mystical relationship between planetary orbits and the 5 regular polyhedra known at the time. Kepler's laws became powerful tools for predicting solar and lunar eclipses, as well as other celestial phenomena. Astronomers could now accurately anticipate moments when celestial bodies would intersect and align, offering a new understanding of celestial mechanics. Kepler's remarkable eclipse prediction abilities generated significant interest, as eclipses were perceived as important celestial signs at the time. The legacy of Kepler's laws became deeply intertwined with Isaac Newton's theory of gravity. By uniting Kepler's laws with the concept of gravitational force, Newton formulated his famous law of universal gravitation. This new understanding revolutionized science and astronomy, laying the foundations for our modern understanding of celestial mechanics. The discoveries of Kepler and the work of Newton were essential to the 17th century scientific revolution, setting the stage for the development of classical physics. As our voyage through the evolution of cosmological thought comes to a close, we find ourselves gazing at the heavens with a newfound perspective, indebted to the bold minds of yesteryears. Copernicus, Bruno, Galileo, and Kepler have transcended history, becoming the cornerstones upon which modern science stands. Their audacious ideas and groundbreaking discoveries continue to illuminate our unwavering quest for knowledge and exploration. As we cast our eyes to the stars that once guided them, we honor these forgotten heroes who shattered boundaries and ushered in a new era of discovery. Just as these celestial luminaries guided their journey, they continue to inspire our boundless pursuit of understanding, casting light on our path to the stars and realms beyond.